It's right during your morning commute, so you do not want to be out on the roads. And then we have lots of snow developing and sticking around all the way through noon. Now on to the latest on the tornado yesterday in New Orleans. In the last few hours, the National Weather Service confirmed the tornado was in fact an EF-3. Here's what we know. It packed winds between 136 to 165 miles an hour. It's the strongest on record in Orleans Parish, and it's left a state of emergency for Orleans Parish and 6 other parishes. For more on this monster of a tornado, let's get over to the lab where Chris and severe weather expert Dr. Greg Forbes are waiting for us. Chris, Dr. Forbes?
Thank you very much, Liana. Now let's take a look, Dr. Forbes, at some of the damage from the air through the eyes, your expert eyes, of looking at some of this damage.
Yeah, and in a metro area, things can get very complicated. Some of the debris that comes off of one building can wind up damaging one of the others. The debris here seems to have come across the street and landed in the yard of that one. Here, the entire roof is off. Here in this building, we seem to have some of the walls down as well. So this is one of the structures that could be getting up to that EF-3 type categorization, 1 to 2 here. But here, most of the building roofs are even intact. So this is kind of in the 0 range. So we do have these little swaths, even inside a fairly wide tornado, where there can be stronger damage, and then adjacent to that, less damage.
And that's also interesting to point out, too, that an EF-3 tornado may not have EF-3 damage the whole way or the whole width.
That's exactly right. There are variations from one side to the core, then to the center of the tornado, as well as little suction vortices, multiple funnels that revolve around the parent tornado that can exaggerate the damage where they hit and minimize it where they're missed. Here's a good example of 2 adjacent buildings here. This one, the entire roof is gone. You see the debris is flown over and hit these buildings, whereas this one, the roof is mostly intact. A little bit of the tar paper, the shingles came off here.
And let's take a look at another piece of video, I believe, that is ready to roll here. And also from the air, Dr. Forbes, what does this one tell you?
Yeah, the same kind of thing. You see a pretty wide damage path, maybe a couple blocks wide here on the left and the right sides. Not as much damage as in this main swath that's coming down the middle. And that's characteristic. Typically just slightly to the right of the center line of the tornado is where the heaviest damage will occur. But even so, there can be these little swaths that come in from the side where these suction vortices hit.
So we can also match this up to the radar. And it's important because oftentimes we don't have the pictures of the tornado or the damage while it's happening, but we do have a look at the radar.
Yeah, and what we know in this case with so many buildings being hit, that it was tossing debris way up into the air, and that shows up on our conventional way of looking at things as a debris ball. Here's the big supercell storm. This is all precipitation coming into a hook, but the tornado forms right inside that hook, and we can see from the velocity, the tornado vortex signature, the blues northbound, the reds and yellows southbound. That's the velocity way that we see an intense tornado there in progress, an EF-3 tornado in progress. This is right over East New Orleans. And then we take a look, the debris signature, that little blue hole there is tumbling debris. All of that red, this is the supercell and the precipitation spiraling around. We go back to the traditional way of looking at that, and that debris signature matches up very well with a debris ball that we see with that high return on radar.
All right, Dr. Forbes, thank you so much for your expert analysis. You will only find right here on the Weather Channel. We're tracking Winter Storm Nico after this.